wonderful good morning from Hannover. It's halftime show and we did not bring Taylor Swift or Kendrick Lamar or anybody else. We brought technology, and today I'm super happy because it's the first time that I'm going to interrogate Roland about everything what he knows about panels and PCs. So I'm very excited what is behind that man actually when it comes to the technology. Furthermore, we have other exciting technological topics. We have PLC++, we have the MX system, and we have a topic which is, I think, important to everybody who builds very big machines. It's motion tools and how they help you to get faster to your application to make it a little bit easier. If you have any questions during these wild ride through automation technology, we are happy to take them through the chat, or you can make an appointment via meet@beckhoff.com. But first, I have the pleasure to welcome Johannes with me. Good morning, Johannes.
Moin.
Thank you for joining me. I have a new topic, which is a buzzword at the moment, almost like economy design. It's cybersecurity. When you type it into Google, you find many different things. You have machinery regulation, you have IEC norms, and you have the Cyber Resilience Act.
You have many abbreviations more.
Yeah, many other ones, ISO 27000, something other. But let's dig into the first three topics. Maybe we can have a short look at them.
About the CRA, the machinery regulation, and the IEC 62443, which is really complicated if you speak that in English, by the way. But have a look at the CRA and the machinery regulation. So both of them are actually laws from the European Union, and they apply to products. So and they both cover cybersecurity. So the CRA, the Cyber Resilience Act, covers the cybersecurity of all products with digital elements. There are many products. And the machinery regulation covers especially the safety, so the functional safety of machines and applications. And we already know the machinery regulation for quite some time because it applies to all of our safety products, for example. But now the machinery regulation got extended by aspects of the cybersecurity. So this is new regarding there. And talking about the IEC 62443, this now is not a law, it's a standard, an IEC standard, as the name suggests. And the 62443 covers the cybersecurity of automation systems and automation products. So there it's really spoken of automation.
Okay, so let's start with the Cyber Resilience Act, because I think that's the hottest topic at the moment. What can you tell me about that in detail?
Yeah, just as said, Cyber Resilience Act covers or applies to all products with digital elements and communication.
So industrial controller to pocket calculator, basically.
Exactly, yeah. Both of them are somehow calculating by display or whatever, communicating, and both have digital elements. That also means if you look at our product portfolio, all products are affected by the Cyber Resilience Act except cables.
Okay, yeah, that's good.
Cables may not have digital elements. That also means that you have to take care of the cybersecurity for all products. The Cyber Resilience Act describes a lot about the process, how you develop products and how you deliver them to your customers and how you support them in the field. Until now, it does not say a lot about characteristics, cybersecurity characteristics of your products, because there just relies on norms and standards, but those standards are not written yet, and those standards are now beginning to written. Additionally said, Cyber Resilience Act starts with December 2027. So after December 2027, products cannot be sold on the European market when they are not Cyber Resilience Act compliant. And how do you get the certification? It's integrated into the CE certification, which we already know. All our products have a CE certification.
EMC characteristics and so on.
Exactly, and the Cyber Resilience Act, so the cybersecurity aspect will be integrated there. So for most of the products, it's a self-certifications company can give themselves.
But that's a very, I think it's a very uncertain situation, because we have a law, we know when it will be in power, so when we have to be compliant to it, but the Cyber Resilience Act itself does not have too many information so far. A lot of standards are currently prepared. How do we actually prepare for that?
Well, of course, we are deeply looking into all our product lines, product groups, and each individual product, and are looking about the cybersecurity features and if we need to add some or if it's already enough. And of course, if we have to add some, which is the case sometimes, but not all of the times. Then we're of course implementing them and delivering them to our customers. And so you're asking, then what cybersecurity features are you looking for? Well, there we are looking for the IEC 62443, which gives us a hint, of course, because it already describes characteristics.
The most tested thing which we have at the moment.
Exactly. So this is the thing most of the companies are holding on to. And on the other hand, the IEC 62443 also has a standard which then describes the life cycle process of a product. So not any characteristic, just the life cycle process. And we are currently getting certified by that.
Yeah. Life cycle is something which you can see here, many products available for a very, very long time.
Yeah.
They're updated and so on and so forth. Okay, a lot of new requirements from the legislative side. Do we have to redesign our portfolio now?
No.
Well, that's very calming.
No, we don't have to redesign our whole portfolio. Of course, we have to implement here and there additional features regarding the cybersecurity. But if you look at our product portfolio, so our classical product lines, you see it here on the booth, IPCs, IOs we have over there, Motion, and then TwinCAT. So especially if you look at Motion and our IO devices, those are mainly EtherCAT devices, which only speak EtherCAT to the left and EtherCAT to the right. And they really benefit from the already good cybersecurity characteristics of EtherCAT, so that it's not an IP-based protocol, that non-EtherCAT frames are simply not coming through the hardware because they're destroyed there, and you also cannot add foreign devices, you cannot insert other devices. So many other reasons why EtherCAT also already has really good cybersecurity capabilities. So 90% of our products are benefiting from that, so we think there we don't have to change a lot or even nothing, and our customers will not see if we change something because it's really internal. And of course, regarding IPCs and our software TwinCAT, that's a little bit different because they are communicating with the outside world, also by IoT protocols. And there, of course, there are standards for IPCs, how to get them cyber secure, just calling them secure boot, measured boot, trusted boot. We are implementing all those features into our IPCs. And for TwinCAT, we have to protect our TwinCAT runtime from the world or from communication and unauthorized process, and therefore we are developing TwinCAT functionalities, especially for the cybersecurity, in order to protect the rest of TwinCAT.
Okay, so a more or less diverse, maybe also a bit of a complex situation, a little bit of uncertainty in the market, but we can tell our customers we are looking out for it. We have many things already implemented and we will continue to do so to serve with compliance.
Definitely, we're on the track.
Thank you. Then I wish you a secure boot into the day here at Hannover. Good luck with the customers. I am now heading to Roland for the super fun part. I will figure out what he knows about panels.
Have a secure walk.
Thank you. Okay, so that was a kind of a different topic because usually we just focus on technology and we focus on beauty, but nevertheless an important one. And beauty is everything what I have right in front of me. It's Roland and it's of course the panels.
Hi.
What can you tell us about those?
Felix, I'm a bit nervous because it's the first time that I'm asked as an expert.
Yeah, me too. I'm shaking.
Yes. Okay, now, well, let's talk about panels because this is actually my real profession, talking about IPCs and panels. Now, if we talk about panels, we have to look back a little bit in history because long time before you were born, Beckhoff built already the first panel and panel PCs because in the late 80s, we had already panels and panel PCs.
C4000, right?
Exactly. Quite a big IPC type monitor, but already industrial graded. Later in the 90s, we came up with the first full-blown series of control panels, basically meaning that the PC was in the cabinet and the control panel was separated with 100-meter distance between both units. It was amazing technology in the last 90s. Next step, in 2012, just a few years after the first iPhone was released, we were able to utilize multi-touch technology, which everybody loves today.
Zooming in, zooming
everything,
out,
yes, the gestures, yeah. So we use this technology and industrialize it with a complete range of control panels already in the 2012. And now, and that's why it's next multi-touch panel generations, we move it up again, new generation with new products to fulfill actual market demands.
Wow. A long history.
Yes.
What have we learned? What benefits are our customers gaining despite the refreshed look?
Yeah, well, refreshed look sounds easy and simple, but it is important. Never forget, this is like the door of your house.
Yeah.
This is the entry card of the machine. The end customer comes to the panel to operate the machine. So I really believe a control panel has the right for a good appearing and a good design. So it's an important factor. But then it's about functionality, because there are functions customers always ask for, which we are now integrating. It sounds simple, but this new push-button extension, which can be modified from customer demands, is already integrated with EtherCAT and also with safety. So just by running one EtherCAT line, you have also the safety function integrated and all EtherCAT signals right into your PLC. That's it.
Very, very comfortable. Let's have a look under the hood.
Yeah.
I know that you are coming from cabinet installation and that you really know how to install a device by yourself.
Yeah. You need to do this once yourself, okay? Because if you look to the back side, I mean, there is always the necessity to run the cables most of the time through a tube or a mounting arm system, and then to connectorize this inside the panel. And this is sometimes a bit tricky. If you have 1 or 2 cables, it's a piece of cake. But if you got 5, 6 cables with Ethernet, EtherCAT, power, communication. So we generated a much larger wiring space. Very simple thing, actually, to give more possibilities to easy wire up the thing. It takes you a heartbeat to wire it up in the future. A big benefit compared to the solution today.
Wow, and it also looks nice from that angle as well.
Yeah, it's also good to look back, good from the back side. But it has to do with function, because here behind this, looking like a little heatsink, actually is the electronics, our self-made electronics. And we start with 4 versions, actually.
Okay.
This one here actually incorporates an Intel Atom CPU.
Okay.
So you can have a 2-core or 4-core CPU. So this is a complete machine control.
Okay.
Yeah? PLC, motion, HMI, everything in this unit.
Not only a pretty face, also an intelligent brain.
Yes, we can scale down with an ARM CPU, and then we can use this as an HMI panel, a web panel, and we can scale down again with 100-meter distance, CP-Link 5 or DisplayPort, all in one unit.
And I think scaling is also another topic, because it's available from different sizes. I think 7 inches, 24 inches over there,
yes,
all the way.
So it's scaled. It's always my big mantra, more or less, to say we have a scalable solution in performance classes and also in sizes. But we forgot one topic. This week is filled with economy products, price-sensitive products.
Oh, okay.
And this covers also this new range.
So you are telling me that it's not only looking good, it's not only very intelligent, it's not only easy to install, also the price is a good one.
Yes, we would like to make it affordable. So the functions people love already today will be even more affordable in the future.
I think that's the icing on the cake.
Yes, it is.
Roland, now we need to have a look into another scalable, very pretty portfolio. Not the door of the machine, but the muscles.
Yes.
I think you need to run into the motion
I do.
area.
Actually, a bit tricky, to be honest, because when we talk about our motion technology, we talk about a huge variety of possibilities. You might know this with all the different drives. We have already the AX1000, 8000, 5000. We have all the different motors and different scales, so the variety is large. And this is by reason, because your application requires so many different functions and features. Now, if you would to understand completely the variety, you need an expert, and I have an expert here, not by accident. We planned this. Good morning, Christian.
Good morning.
Now, if we want to get some light into the dark, of course, we can have somebody from our sales team, application team, or youth and product management, and he explains all the functions and features. But we also have a software tool which can help the customer to easily configure his application. So what is this tool all about?
Yeah, we designed it to help our customers, mainly the mechanical guys, to find the right solution for their mechanical load case. So finding gearboxes, drives, and later on the cables and the motors and so on. And yeah, I can show you in a short way what it looked like. So this is our motion designer. On the left-hand side, you can see different load cases like this belt drive here, or there are several other ones. So the mechanical guy selects then his load case and has to set up all these mechanical data of diameters and lengths and so on, and also the load that has to be transported through the machine in a specific time. This is a very complex load case, like a crank gear, but all is supported in vertical, horizontal way. And after that, we design how the machine should behave through the mechanics, and define the motion profile for that. That could be a CSV file or our 7-segment profile.
Okay.
After that, we select the components. We get a torque curve for the gearbox and the motors. And if everything is green, we found the optimized motor, we found the optimized gearbox, get a bill of material, and there we have only to select, is the shaft of the motor a smooth shaft or feather key in, or which encoder we want to use for, and if it is for safety, needs it a holding brake. At the end of this selection, we get a report of the individual axis, and the work is done.
So this must have been done all manual in the past. Well, we can use this tool for a while already. It's not a brand new tool.
I did it 20 years ago manually with calculation
now
and formulas.
It's guided through like a configuration system. But Christian, I think you made it a little easy pass because this is just one axis. And honestly, who needs only one axis? So I think this is too simple. So what is the next level?
For sure. You have to do that for several axes.
Yeah.
Today's machines have 20 axes, 100 axes. So you do that several times and start this process then again for everything of that. After that, we get a DC link overview. So all these axes are connected to one power supply. They share the energy. And we see in this overview what we did up to now. So we have the different axes, which motor is connected to that, which load case and mechanical data are connected to that. But the most important thing is then this overview, how much energy these components need. And it's not only that one motor starts at the same time like the other one. One is starting, the other one is decelerating and giving energy back. So the power supply is usually not that big like all the sum of the axis power. So with this, we see that and can select a braking resistor, or we can select the right power supply. We can find out if a regenerative module can do that job. And also here at the end, we get a complete bill of material of this complete machine that will be presented to our sales guy. And if he does a good job, he gets that job and we get the order.
That's what a manager loves, that there's a bill of material at the end and we can get the order, right? So perfectly done. Now I got the bill of material. That means I place the order. Hopefully everything is on stock, which is actually very valid these days. Parts are delivered. So what is the next step for the customer now?
Yeah, then we have to get that up and running.
Yeah.
So in the meanwhile, the design guy has to do the sketches and get also the EPLAN macros out of our tool and so on. If that is all set up and the cabinet is already there, if we are lucky, power is on.
Good choice, power is on.
Yeah. We have our drive manager for that integrated also in TwinCAT. And there we see which power is connected. If it is single phase or three phase, we can select tolerances for different countries, which is sometimes necessary. Select if an external or internal braking resistor should be used. And because all of our components have electronic nameplates, we also see for specific motor, a specific speed torque curve, how the motor behaves then. We can see there what the setup is for the NC connection, if there's a specific gearing in between. But this is then the highlight of our drive manager. With one click, we get the axis running and we get it tuned. That's the main thing.
So auto-tuning is auto-integrated?
Auto-tuning is also integrated. One click on the start button and we see here a difference of 1 to 70-60. So the axis is optimized for hard running. We have a scope integrated and can see how it behaved before, for the auto-tuning, and after that. And we can see that all these spikes that we had before are gone. So we have a very smooth behavior then of this axis. And that happens within 2 or 3 minutes.
Wow. So with the motion designer, I get the right bill of material. And now, as you're the drive manager, I basically get it up and running.
Yep.
So what do you do in the future?
We do optimizing the software and hearing your customers adding some new features.
I think this is great because a lot of people really sometimes get confused with the large possibilities we have, and such a tool is a great help for our customers. Thanks for the explanation, Christian. Now, a great help for the customer, this is important. And the next topic is a perfect example for a great help, because instead of assembling everything in a large cabinet, we can shrink it down now to our cabinet-free automation. Felix, take over, please.
Yes, and I think exhibitions are still a thing. So a lot of stuff is going on here, very crowded booth. We are happy that it is that way. And we think that one of the main reasons is because we have amazing automation technology, and especially the AMX system. But before we go into that, Kai, thank you for joining us. If you are looking at a traditional control cabinet, what do you think, what would be the efforts to do the schematics for such a control cabinet?
Yeah, first of all, thanks for having me.
It's a pleasure.
To answer your question straight, It depends.
Yeah, that's the best engineering answer.
Exactly. It depends on the data you have, it depends on your skills, it depends maybe also on the system you are using. But let's have a look on the whole process of designing a control cabinet.
So it's more than the schematics, right?
Exactly.
Yeah.
Everybody knows the multi-line drawings represents the single connections in the cabinet.
Yeah.
But when we think further, the cabinet needs to build. What does it mean? We need to make a panel layout, the arrangement of the components, everything needs to fit in the enclosure. The next step, when you have everything in, all the components have heat loss. That means you need to make a calculation if you maybe need an air conditioner, because it's a closed system.
Yeah, that's true also.
And on the end, somebody needs to build the panel. You need to deliver a documentation to your workshop that people can wire it, have drilling patterns, and so on. So you see, it's a lot of work to finalize electrical engineering for such a cabinet.
Ah, okay, many different things to be considered, otherwise it's not working at the end. Do you have a kind of a philosophy? Do you arrange by color, by function? How would you do that?
Yeah, color is maybe not the best example, but
It's also mixed up here.
yeah, exactly. Yeah, the traditional way, I guess, and still many people work like this, is that you start with the power supply, with the income, so the big stuff. Then comes the power distribution, maybe the drives, the motors, and so on. And then we start with the lower stuff, the 24 volt or 48 volt, and the distribution of the control voltage. And finally, the IPC or PLCs and the IOs. This is the traditional way, but nowadays we have a standard for functional orientated engineering,
Okay.
IEC 81346. This is functional orientated, and that means when you have a machine, you divide the machine into several modules, into several functions, and you represent also in the electrical drawing each function, if possible, on 1 or 2 pages, what makes it easier for us electrical designer and for the maintenance people.
So you are following with the electrical design, the actual machine design.
Yes.
Now, Kai, we have set this up a little bit. So this control cabinet represents a certain set of function, which is right behind you,
Yeah.
represented by an MX system. So all of the functionality which we had in that control cabinet is also in here. How does this make your life as a planner, how does it make it easier?
Yeah, the MX system is designed according to this philosophy to divide the machine into modules and functions. That means each automation function, like drives, IOs, and so on, represents one module of the MX system. If you have a big machine, you can divide the machine into small modules and can use one base plate, place all the automation functions which are available on one base plate, and mount this base plate on your machine. And for the drawings, it's the same. You have for each function maybe one page, and then it's much quicker.
So it's following the philosophies, your philosophies, and also the standards. It looks like the mechanical design and the electrical design are really going together. Yeah, they are one thing in the future.
Yeah, for people who make functional orientated design, this is the big wish that mechanical department and electrical department gets closer. But that is a challenge for the next years. But finally, this is the way how we design on a modern way.
Wonderful. Thank you very much, Kai, for having your look from an external perspective on the system. You will be on the booth today with us for a little bit.
Exactly.
I wish you a lot of fun doing that. And now I have to transition to Bela, because we have not discussed anything about PLC++. Thank you, see you later. And this was one of the big highlights in the last year, our own PLC compiler. And what's new there, what's going on there, this is now going to be discussed between Roland and Bela.
Yeah, and some of you might remember that we presented PLC++ already at the SBS trade show in Nuremberg, which was November last year. And in this last 5 months of presenting the product, we gained a lot of experience and a lot of interest and a lot of questions. And some of the questions I think we will answer now with Bela. Good morning, Bela.
Morning.
Now, you are part of the release program and you're part of the product management team for PLC++.
Yes.
So what are the reactions after the presentation a few months ago?
So far they are great.
Yeah.
We have presented it the first time on the SBS show last year in November. And we actually won the highlight forum for the TwinCAT team.
Yeah, we are back in Highlight Forum here, right?
Yes, indeed.
Congratulations.
Thank you. And we took the space we got here to bring 6 additional workstations with us to only show TwinCAT PLC++ live to as many people as possible. And it's not only the idea of the performance boost on runtime side, it is also, I think, the basic idea not to change the whole TwinCAT system, but only to add another PLC module, which is much more performant, but also the engineering side is much more efficient. And in between, we already had various customer meetings where we also showed the software live, and the feedback was very good.
Now, before we talk about the engineering features and functions, I just got 2 questions in our chat.
Okay.
I think we're going to answer them right away.
Okay.
So the first question is actually, we are offering for the Linux runtime, the Linux-based TwinCAT, also a beta program. I think this is correct, isn't it?
Absolutely correct. There's a specific beta program running right now.
So customers can subscribe,
Yes.
apply, and then they get the program. Now, the question is actually, are we going to plan the same with PLC++ in the near future?
Yes, of course. So there will be a beta version available beginning of next year. And this will be an open beta, so everyone who's interested can download the beta and start testing it.
Okay, thank you. And if you got a real interest, the beta is running here on the booth, like Bela said before, on 6 workstations. So just come to Hannover and you can practice right away. Now let's go back in the technology. And you said there are also optimization in the engineering.
It is.
So is engineering easier, or what is the opportunity?
So if you start your laptop tomorrow morning and you open your TwinCAT and you are using TwinCAT PLC++, it will load faster. So this is first optimization to be more efficient in the engineering side. But we want to also support you during the daily business, so during programming phase. And in this case, we are offering totally new editors, and we have added quite a number of usability feature here. So for example, we are introducing code snippets. These are kind of templates which you can use to program very fast.
Yeah.
There is also code adding automatically possible. So if you are programming your state machine, for example, you beforehand had to write down all the states manually, but in this case we can just automatically add them for you. So these kind of optimizations are added in the new editor, but there are also online features we have added. And just to mention one, let's say you have delivered your machine 2 years ago, and you are now doing the service on the machine and you want to connect with your project. But maybe it's not the current version, it's not fitting to the version running on the machine. And this is where we are adding an online feature to easily compare the code running on the machine and which you have on your laptop. So these kinds of features are added to make the engineering in total more efficient.
I think this is amazing because we are normally known to optimize always the performance at the runtime side to be faster, more accurate, and so on. But now we're also thinking on the programmer side, even at the engineering side, to optimize the
Absolutely.
Now 5 months experience with first market researches by a purpose early launch. So what is now the next steps?
So we will definitely concentrate on the structured text editor. This is for us very important, and we do have quite a number of additional usability functionality in mind, which we will implement. But there is also a very important other component, which is the converter. Because it should be, of course, as easy as possible to switch from TwinCAT PLC to TwinCAT PLC++. And this is something we are also going to concentrate on.
Right, perfect. So you have started a marathon to release the product last November. You're still running in full power. Excellent.
Absolutely.
We have the finish line later this year, so thanks for the insight, Bela.
Thank you too.
And thanks for your questions. There are a few more which showed up. And one is actually about explainer. And believe it or not, I have an expert with me for explainer. So what is the question all about, Felix?
The question is about payload. Payload with explainer is very simple. It's scalable.
Yeah.
Small mover, 1.5 kilogram.
Okay.
Bigger mover, 4.5 kilogram. But when it gets really heavy lifting, really heavy lifting, you need to work together.
Okay.
That's why we can couple the movers together. If we have 10 movers, we can transport, for example, 45 kilograms. And I think about this size of a tile would be maybe 20 movers.
Yeah.
Maybe could carry you. So next time we will have a floating Roland here on the show.
Okay. So, but again, a mover is maybe this size, and it can already carry 4 kilos, correct?
It's that size roughly is 4.5 kilos.
Okay. There are a couple of more questions which you're going to answer in the chat as we're running out of time. So, but we will answer anyhow. You can keep asking us questions, meet@beckhoff.com for emails or the chat window. And then we go working on the booth, and we're going to see you tomorrow again, because there is another day. Day number 4 is coming tomorrow. So thanks for joining. Have a great day. See you tomorrow.
Thank you. Bye-bye.
Bye.